BlogTalk Radio.
Welcome to the AME Food Testing Show. Today's guest, Joshua Jones, founder of Fish&Loaves Food Safety Consulting. Today's topic, ATP testing versus other types of tests for environmental surfaces. After beginning his career in quality assurance as an internal quality process auditor for a medical device manufacturer, Joshua applied his education and quality background in medical device manufacturing into the food industry as a food safety and quality specialist, regulatory consultant, trainer, and sanitarian for a privately owned vegetable grower and processor, as well as an international ingredients manufacturer. Joshua possesses a bachelor's degree in biology with a minor in biochemistry from the University of South Carolina. Joshua is a certified safe quality food practitioner and auditor for both the ISO 22000 food safety and ISO 9001 quality management systems. He's a registered ServSafe instructor and proctor and conducts these trainings on basic sanitation practices and principles for the restaurant industry. Now, welcome with me, Joshua Jones, to the program. Joshua?
Hi. Hello?
Would you like to update our listenership on your current activities beyond the introduction I just gave?
Well, I have actually started a good bit into more of the regulatory side of things, dealing with regulatory affairs and those specific items. And other than that, I mean, it's just food safety as usual, right?
It's a challenge, and as you and I have discussed in the past, it seems as though there is a recall almost daily.
Yes, sir. It does seem that way.
Well, today's topic begins with the primary inquiry is why test a food contact surface for bacterial contamination in the first place?
Well, it pretty much leans to what we spoke of earlier and just what you mentioned, a few seconds ago with the foodscape, as I like to call it. We're seeing a lot of recalls. We're basically littering our foodscape with recalls. And while a lot of these recalls are actually sourced with physical contaminants and chemical contamination events and things like mislabeling of allergens or declaration of allergens, the lion's share of the recalls that we are seeing are related to microbiological contamination with pathogens. And so when you see an actual pathogenic contamination event and a recall associated with that, what it implies is that somewhere along the way there was an issue with a sanitary operation somewhere. Somewhere a sanitary operation failed. And while cleaning and sanitizing definitely isn't the only sanitary operation that could have failed and resulted in an actual recall, a lot of the times it is one of those programs, one of those things that are really pointed to because it's just so easy to contaminate a product with a surface that has not been cleaned and sanitized well. And so with that, since cleaning and sanitizing is so important to preventing contamination of food product, it also follows that it's very important that we assess the how well we're doing in terms of cleaning and sanitizing to make sure that we can mitigate the risk of food contamination and potentially reduce the occurrences of recalls that we're seeing out there today.
Well, Joshua, your introductory remarks about sanitizing and cleaning leads us to how do we QA or quality check the quality of our cleaning, and what is ATP technology?
Well, ATP technology, and I'll take that part of it first. ATP technology is used most widely throughout the industry of food processing and others as well. It's most used to assess the cleaning effectiveness of surfaces, and it's usually done pre-sanitizing step because in sanitation there's a cleaning of a surface to remove soils, and then there's a sanitizing step to actually reduce and kill off any pathogens that may be on the surface. And so that's what the ATP technology is actually used for, to assess that cleaning effectiveness. And so the way that it does this is it actually searches for ATP, or adenosine triphosphate, which is an energy molecule, is the best way to describe it. It's an energy molecule that is present in all organic materials, living or once living, and that once living part is debatable, depending on who you ask, but living or once living. And the way that it does this is through the bioluminescence reaction. And before I begin with all the jargon associated with the bioluminescence reaction, this is a reaction that's most readily seen in fireflies, or as we say down south, lightning bugs, so to speak. And so this actual bioluminescence reaction is a reaction between luciferase, in a general, just trying to keep it general, luciferase and ATP. It's essentially an enzymatic reaction. And so what's emitted from this reaction, or what results, is actually light, some level of light. And so what the ATP technology is set up to do is actually read this light, detect it, and then translate it into a number or a quantifiable piece of data that we can use to assess the cleanliness of surfaces. So that's essentially what ATP technology is and what it's used for within a cleaning and sanitizing regimen.
So, Joshua, what are the advantages or disadvantages of ATP testing?
Well, in comparison, well, I won't compare it to conventional testing methods too deeply, but just comparatively speaking, there's a lot of time saved between ATP testing technologies and the conventional platforms. Now, when you look at ATP testing, you have one of two things going on. You actually have the general platform, which looks for total organic soils, so anything from dirt all the way up to and including microbials and bacterial presence. You can basically get a result in about 15 seconds roughly, and that's pretty quick, comparatively speaking. The more selective platforms, you're looking at somewhere between 1 and 7 hours. The lower end of that would be more of a pass-fail situation. The higher end would be trying to get some numbers out of it. And so that's one advantage, just time saved. And as we move forward in looking for real-time results to, make decisions like dispositions on pieces of equipment and things like that, this becomes very important, a very important advantage. Another advantage that I see with this is that now we're able to really quantify clean. At one point, it's just based off of a traditional inspection. And there, you can subjectively say the surface is clean, but now with the oncoming of ATP technologies, you're actually able to stick a number to it and live with that number and say that it's an objective number. So that's another advantage of this. The third advantage of it, and it's more of a soft one, is in the way of cost. Cost in terms of manpower. It takes a lot less time to do this kind of test on equipment versus conventional testing. And so you save some money on the front end, just right off the bat with time there and the amount of effort that's required to actually run a test like this. And I won't make any plugs for any companies, or I'll let them debate this one, but equipment costs can be considered an actual advantage for this. It's slightly less, and some companies would argue that it's significantly less than implementing a conventional program. But those are some of the advantages. One big disadvantage that I see with this is that with the general platform, that's the one where you're looking at total organic residuals, you can't really quantify or rather correlate the numbers that you get out of this to bacterial or microbial loads or counts. So that's a big disadvantage there. And a big reason for that is essentially that, just as different people of different sizes, weights, heights, and everything in between have different levels of energy and actually put out different levels of ATP, bacterial counts and microbial counts can actually be comprised of a few different kinds of microbes, all pitting out different forms of ATP, not different forms, but different levels of ATP rather. And so you really can't quantify the number that you get off of the screen to bacterial counts because it may be misrepresentative of what you're really looking for.
So let me summarize. So the disadvantages would be an apples and oranges comparison to traditional culture methodologies. Is that correct?
Right.
But it is a helpful tool on the advantages side in times of short turnaround times and a general indicator during the cleaning and sanitation process. Is that correct?
Right. That is exactly right.
Perfect. As I was reading your introduction, Joshua, I was very impressed that you are both an SQF practitioner for both ISO 22000 and ISO 9001. What are the audit guidelines regarding ATP screening for food?
When you speak about audit guidelines pertaining to the use of ATP technology, in the context of a food processing facility, the general idea behind the testing guidelines is really to have a standard assessment of your entire program, because that's really what you're trying to go after. Is it effective? And how well are we actually assessing this? Is the equipment actually doing the job that we want it to? And so when you approach audit guidelines, things like consistently using a 4-inch by 4-inch surface for testing becomes very important, because if you go around sampling things at different sizes, you don't get a consistent reading on pieces of equipment across the processing landscape or your actual program. And so that's one important thing, just standardizing everything. By doing that, another method or another piece of that is that we really don't want to overload the swab. That also gives you some screwy results and doesn't really standardize very well the testing that you're trying to do across your program. Now, in the context of you mentioned ISO and you mentioned SQF, all these different food safety management system certifications, when you look within those, it puts a really big importance. They put a really big importance on cleaning and sanitizing, because it is a basic prerequisite program, and it holds up your HACCP plan. And so you want to make sure that it's effective, that it's verified, that it's validated. Now, these platforms, especially the 9001 or the 22000 rather, they require that your program is validated. And so that validation, it can come in two routes. Of course, you can use the route of background scientific data from a reliable source, or you can use in-house data, inline data that you collect over a period of time, over a determined period of time. And so as you begin to implement ATP testing for your cleaning step, it can become a very good tool for validating the cleaning step if done properly. And then when I mention properly, it will also include some environmental monitoring to confirm that your cleaning step is really making way for your sanitizing step. And so
excellent. That leads to my next question.
Yeah.
That leads to my next question, Joshua. How does a food production, food quality, food safety, and food security manager engage ATP testing in their food safety plan?
When you look in your, when you look at what an actual food safety plan is and an overall kind of global purpose, you're really trying to mitigate food hazards and trying to mitigate risk. And one of those risks, as we mentioned earlier, is that of microbiological contamination through surface contact. And so when you begin talking about engaging ATP testing, it's really important to integrate it. Well, first go into it with the mindset that it is there as a control. It is there as a control point, and to actually verify an actual control point. And so once you start viewing it in that light as, a control point rather than, this is just something that we have to do to satisfy the auditors or to satisfy the regulators up in Maryland, then it actually becomes an integral part to your actual food safety management system. And on the back end of that, or rather in concert, actually, the communication of it is actually key in implementing an ATP testing program within your facility. And along with that, it's important to understand that ATP testing, once again, does not give you an actual specific count or grasp of what kind of bacterial loads you're seeing. So it has to be used in concert with some other form of environmental testing, which is generally more often than not, it's more plating of specific pathogens to ensure that you're reducing pathogenic loads and items like that.
Well, Joshua, you opened the question, what types of decisions are driven by ATP testing when we're looking at the very narrow spectrum of results that it gives to managers? Well, as I said before, what ATP testing does is it assesses the cleaning step. And so what you really begin to see is that when the testing is done prior to the sanitizing step, it is actually used as a release for equipment surfaces to be sanitized. It's basically giving the sanitation manager or the person performing the test the data to tell someone else to say, hey, this equipment is good for sanitizing, go ahead to the next step. So those are one of the kinds of decisions that you're seeing made with this, and it's actually the biggest decision that you're seeing made. Other decisions, we spoke about recalls earlier and a lack of, or rather a failure in sanitary operations. At times, I've seen ATP testing actually used to determine root causes alongside environmental testing, obviously. So that's another decision that I'm seeing. And then also within the food safety management system, within that scope, you're actually seeing the results of ATP testing being used to feed back into your system of sanitation, your system of cleaning and sanitizing to say, hey, this is effective. We can go forward with this. It's working for us. Or, hey, this cleaning
step here is not working. We need to alter it and move forward. So corrective action and preventive action, you're seeing these results being used for.
Well, Joshua, you raised some interesting issues. I'd like to explore one of them. And you mentioned that we could use ATP testing as managers to look at our critical control points and also corrective action points. Would we vary the testing locations or keep them the same every time?
In terms of, could you repeat the question? Kind of breaking up over here.
As we're collecting ATP data, would we randomly vary the testing location or only test those specific locations every single time?
It depends on the size of your operation, and then also it depends on it honestly, the other piece would depend on your actual food safety management system itself. When ATP testing is used as a control point, you generally see it at those strategic points in your operation. If you have done testing over a period of time and you keep seeing issues at one point, you keep seeing failures at one point, a sanitation manager or a food safety manager may pick that point to be a control point there. That's one way that a strategic decision could be made regarding the placement of a testing point. Also, you could essentially look through your flow map, look through your process, pick out the toughest pieces that you would think that a sanitarian or a sanitation team member cannot reach, and pick that point as one of your control points. At the same time, you can go through that same flow map and just pick points that are later in your process, because those are the last points that leave that the product touches as it leaves the door. And so there are many ways that you can actually pick these control points, but each of them must be strategic and based on sound logic or sound data.
Excellent. So, Joshua, what I'm gleaning from your remarks are an evidence-based research project and monitoring of the food contact surfaces is part of a sound food safety program. Is that correct?
Right. And the general, and that's exactly right. I mean, the general traditional method is more subjective, as I mentioned before, where it's just an inspection. Oh, this looks clean or feels clean. With an ATP monitoring system, they can give you quantifiable data. And if you can get quantifiable data that's subjective, then that's the perfect setup for you to ensure that your surfaces are clean and that you're reducing the risk of food contamination.
Excellent. Well, I'd like to allow you now time to review for us from the beginning. Why do we test food contact surfaces? What is ATP Technologies? And without naming any names, what are the advantages and disadvantages and all of the other issues that we've discussed in our interview, and to summarize them prior to terminating the interview?
Okay, sure. Quite a tall order you've given me, Andy. I will try my best. Well, essentially, the reason we want to test food contact surfaces for bacterial contamination is because it is such an important thing. It's so important to do that, because it's so easy to contaminate food with a surface that hasn't been cleaned adequately and sanitized adequately. And so what we see is that ATP testing is a good solution for verifying that we're doing this effectively. Okay, and so ATP Technology, the way that it does this for us is that it uses a bioluminescence reaction, which looks for ATP, and ATP is adenosine triphosphate, which is available in every organic material, living or non-living. And so basically it goes on a search mission for this ATP and actually translates the ATP into an actual number that we can use objectively to monitor the effectiveness or to verify the effectiveness for our cleaning and sanitizing program. Some of the advantages of this are definitely related to cost and time savings, and those two are really intertwined quite closely when you actually look at the advantages of this. When you look at time savings, more specifically, that on the shorter end of the actual testing time with ATP, you're looking at 15 seconds, and that is amazing in terms of how long that test actually takes when you compare it to other methods out there that take a bit longer. For general, it would be a general inspection. Another advantage for ATP testing is that it gives you quantifiable data, that it gives you data that you can use in hard numbers, and you can show team members, you can show other sanitarians, hey, we checked the surface and it has exceeded our limit for this actual test. It's exceeded our actual control limit, and we need to re-clean this before we can pass it on to the sanitizing steps. So those are some of the advantages. Disadvantages, the biggest disadvantage is that with this, with the general test, you cannot correlate these numbers, which are looking at general soil loads, to actual bacterial counts. And that's most simply because different bacteria, different microbiological organisms put out different levels of ATP. And since the ATP testing is searching for ATP, what you end up seeing is a mix of soils and then microbiologicals that put out different levels of this stuff. So you can't really correlate the two there.
Excellent summary, Joshua. I'd like to allow you some time now to talk about Fish&Loaves Food Safety Consulting, some of your products and your services that you offer.
Sure, thank you. Fish&Loaves, we are a food safety consulting firm, and some of the services that we offer are obviously training in ServSafe and training in general food safety practices, also creating training programs that are specific for operators and specific for restaurateurs and facilities. But then pertaining to this actual discussion, we also have services that include sanitation program development, and that includes the planning, training, verification, validation steps, and then also some coaching services there. So that's the general rundown, the quick rundown of some of the services that we provide.
What types of clients do you engage, Joshua?
We actually look at a couple of sides of industry, of the food industry. We work with processors, primary producers as well, and then we also look into the retail end of it with restaurants and grocery stores and things like that.
Very good, Joshua. I'd now like to allow you any closing comments prior to the termination of the interview. And in that, also thank you for your wonderful participation today. You are a valued contributor, and if you ever think of any other topics that you'd like to discuss for our food production, food quality, food safety, and food security managers, I invite you to come back.
Okay, well, thank you. And first, let me start by saying I really appreciate the opportunity to be a repeat offender, Andy. Thank you, on your show. As far as closing remarks go, the subject matter that we covered here is very important. Obviously, it's one that's dear to my heart, and if we can help any of you out there, processors or on the retail side of things with implementing this kind of testing, then we are more than happy to do that, along with other food safety development and training opportunities that you may have. And once again, I appreciate the opportunity, Andy.
Well, thank you so much, and wish you a great evening.
All right, you do the same.
Bye now.